Welcome to solverfy.
So we are given that hydrogen exists on the surface of most stars, right, in very large amounts, but the observed spectrum or absorption lines are the highest intensity when the temperature is about 9,000 kelvins. And when we are looking at higher temperatures, the absorption lines actually become weaker. This is when it is the strongest. Now, one of the reasons why is probably because our absorption lines come from a various source of light from around the or source of energy from our various surroundings, right, or from the star itself. From the star, we are actually emitting out visible light, and so the hydrogen must absorb some of this visible light in order to show us the absorption lines, right? But as we know, the visible spectrum lines from hydrogen actually comes from the Balmer series. And the Balmer series is when the hydrogen starts off in the first excited state, E2, and absorbs up to the other excited states, right? So this is when we will have the strongest intensity. So at 9,000 kelvins, it is likely that a lot of the population of the hydrogen atom is in the E2 state, or the first excited state. And as such, we will absorb a lot of the visible light range, and therefore we observe a very, very strong intensity of absorption lights. However, when we go up to even higher temperatures, to 25,000 kelvins, we expect maybe now the hydrogen atoms will mostly be in the even higher excited states, say E3 or maybe E4, right? So they'll be in either E3, E4, and all these absorption lines would be in the infrared region, right? IR region, which is not really the source of the light that is coming from the sun, right? The sun mostly is visible light, so it will only absorb infrared radiation, and therefore it's not very, the absorption lines are not very strong. Same thing if you were to consider cooler stars, that is a temperature at about 3500, then the hydrogen might mostly be in the ground state. So if they are in the ground state, then we will observe the Lyman series. And for the Lyman series, as we know, they are mostly in the ultraviolet range. Once again, because it is in the ultraviolet range and not the visible range, we would not observe a very, very strong absorption in the visible light spectrum, and therefore the absorption lines will be not as strong.